Okay, so we're going to work through these Punnett squares. So first of all, when we're looking at X and Y linked genes, and in this instance we're looking at X-linked genes, we're going to put a superscript next to either the X, or if we were looking at Y-linked, next to the Y. Okay, so here we're looking at X-linked, and so we put superscripts next to our X's. We're specifically looking at X-linked recessive genes. So we have a lowercase n over here designating the recessive and uppercase over here designating the dominant. So this is an affected male because he has one copy of the X-linked recessive gene. He doesn't have another X, so he's always going to show the trait. Okay, so over here we're going to cross an unaffected female with an affected male. So first we're going to put the possible sperm on the top. So remember, the two alleles are going to split. So we're going to have one sperm that has the affected X, so it's carrying that recessive allele, and the other sperm is going to have the Y. The female, the two possibilities for the eggs are the same. So they are both X's, and they have the dominant allele, which is not affected, does not confer the trait. Okay, so let's see what happens when we cross this. So first of all, let's look at the daughters. Okay, so daughters are going to occur when the X sperm meets the X egg. In both of these instances, we're going to end up with carriers. So all daughters are going to be carriers. So you can see these daughters have one X, which has the dominant allele. Remember, the dominant allele is not the affected one, it's the recessive. Okay, here is the X with the recessive allele. Okay, so this female is a carrier, and so is this one. So all females are carriers. All right, let's look at what happens when we get a male. So here we have an X and a Y. The thing to note is that this X came from the mother, and this X came from the mother. So sons always get the X chromosome from the mother. So in this instance, we have the unaffected X, okay, as the dominant allele, and the Y. So in both sons. So no sons are affected. All right, now let's look at our next Punnett square. So here we have a carrier female. And if you want, you could almost think of this as the next generation. So you could almost think of this as one of these daughters over here, okay, because these are carriers. So here we have our carrier female, right? So they've got one dominant allele and one recessive allele. So remember, it's the recessive that carries the trait. And we're going to cross that with an unaffected male. So this couple may have no idea that either of them is carrying the gene. All right, so again, we're going to look at what are our possibilities for sperm. So we've got an X carrying the dominant allele and a Y. And then for the eggs, we've got one X with the dominant allele and one X with the recessive allele. All right, so now let's look at our possible daughters. So if we cross this X in the sperm with this egg, we're going to get an unaffected female. So they've had two dominant alleles. If we cross this X with this X, we're going to get a carrier. Okay, so this female has one dominant allele and one recessive allele. So not going to show the trait, they're just going to be a carrier. All right, now let's look at our males. So here we have one X with a dominant allele. Again, remember, all sons get their X chromosomes from the mother, right? So this is this X right here. All right, so we've got one X with a dominant allele and the Y. So this is an unaffected male. Now here we come to the crux. So we have an X that's come from the mother, right? So this is this X with a recessive allele and Y. So this male is going to show the trait. They don't have another X to sort of cover up that recessive allele. So all males with just one recessive allele are going to show the trait. So this male is going to be affected. So here we have two unaffected parents, and they have a 50% chance of having a male with the trait. All right, let's go over to our third possibility. Now, this is pretty rare in X-linked recessive traits. So in this instance, we have a male with the trait, and we have a female who is a carrier. Okay, so let's split these alleles. So we're going to take the two male alleles and put them down here in the sperm. All right, so we've got one with the trait. This is the recessive allele, one with the Y. And then we've got the two X chromosomes down here, one with the dominant allele and one with the recessive. And now let's cross this. So let's look at our females first. All right, so we have one X coming from this sperm. This has the trait, it has the allele there. And then one X coming from the egg. Okay, this is a carrier female. Here is our second possibility for a daughter. And this would actually be an affected daughter. So here we have the sperm carrying the X with the affected allele. And we have the X in the egg carrying the affected allele. So here we get a daughter who has the trait. So that would be pretty rare for that to happen. So it's 50% of daughters from this cross. All right, now let's look over at males. So in this instance, we have our Y, and then we have our X coming from our mother, all right, from the egg. And so this is an unaffected male. And then here we have an affected male. So remember, this X comes from the mother, okay? So this is the X with the recessive allele and a Y from the father, so giving us an affected son. So again, this is pretty rare for this to happen. These are two more likely explanations.